So going on to variables and variable data types. So again, programming is not limited to only printing simple text on your screen. That's all we basically did yesterday. We just focused on printing out like hello world in like two different ways, but at the end of the day, they both still did the same exact thing. So in order to go further, we have to be able to create variables. So if you remember, yesterday I asked you to do like this little mental math kind of program, and it's just meant to like simulate how you store memory and how your computer stores memory. So just like I told you, you would remember the numbers 5 and 2, and you do some sort of operation on it. Like you might be adding 5 and 1 to make 6, and then subtracting 2 from 6 to get 4, without you writing out all these steps. You keeping that in your memory and remembering all those steps is the same thing that your computer does whenever you ask it to perform the exact same operations. So that's all this slide is talking about. So it's just like an introduction to like conceptually for you guys to imagine what do variables mean when it comes to like looking at variables, and how does your computer store memory. And so this is again just a simple math program. You don't have to worry about this right now. We are going to go over this again like later on today. So by the end of today's lesson, you should be able to look at this and this looks like a piece of cake that you completely understand it, but don't worry about it. This is just basically us showcasing that the same mental math you did, your computer can also do. Yes, and somebody said you can't store too much memory because it will crash your computer. That's absolutely correct. So just like how you can't memorize, like, okay, some people can, they're really great at it. But sometimes after a while, you can't memorize like a lot of strings of numbers together. Like a lot of people try to memorize the full form of pi, for example. You'll start getting a headache and you'll start kind of like forgetting what the numbers are. Your computer is just like that as well. So if you store too much memory, your computer will crash. So this example basically just showcases what variables are. So in the above code, the variable names are A, B, and result. So we could have called these anything, right? I could have called 5 equals C or 2 equals X. It doesn't really matter. The point is that you're just setting it equal to something so that your computer actually remembers it as it is. But these names, again, have to be valid identifiers. So if you remember from yesterday, we went over basically a bunch of random rules. Okay, not really random. We went over a bunch of rules that are important for you as a programmer to remember whenever you are creating your own data type, whenever you're creating your own variable. And so if you remember yesterday, we did this little exercise and I asked you all like which of these identifiers are correct, and all of you smarty pants all said that yes, answer is the only one that's correct out of here if we're looking at the rules that are provided here. So I shared the screen like this presentation slide with you. Remember, it's part of like the Google Drive link that I sent to everybody. So if you ever are like confused or you ever need like clarification on what the rules are again, please like always refer back to this slide, because this is not only like good style. If you remember from yesterday's discussion, style referring to like the way you write, but it's also good syntax. It's good grammar. This is like proper for your computer to even like properly identify variables and properly create variables. But yeah, again, this slide is just showcasing what counts as a valid identifier. Again, C++ language is case sensitive. So basically this means that your language has to have both like capital letters and lowercase letters, and that your computer looks at these letters in completely different ways. So again, the result variable, all capital letters, is not the same as result variable without capital letters. And this kind of result variable with just one capital letter is not the same as this variable or this variable. So it's really important to know what the differences are between like capitalizing your letters and not capitalizing your letters. You as a programmer have to be careful about that. And this last one just basically says like, what's the list of keywords? So someone asked a great question. They asked like, what happens if a command starts with an exclamation mark? So an exclamation mark is not a valid identifier. So in this case, you will learn, we'll learn about exclamation marks, and they count as a not. So that's actually like a separate operation, and I think we're going over that today. So we might have to hold on to that, but you definitely cannot name a variable with an exclamation mark. It does count as one of these like special symbols. So I think I wrote that here, yes. Symbols cannot be part of an identifier. And when we're talking about symbols, like exclamation marks count as a symbol. So you can't create a variable name that begins with exclamation mark. But exclamation marks are actual operators that perform a function in the program as well. So they do mean something, but they just cannot be a variable name. Okay. So next slide is about actual data types. So what are data types? So again, the computer stores values as either zeros or ones. So if you remember, your computer stores everything in terms of binary, which is completely different than the way we actually process information. Even like in mathematics, we do everything by logarithms of tens. So if you think about it, you always have like single digit numbers and like double digits, but all of those are like the tens places. We use tens to 100s to 1000s, and that's different than the way your computer actually stores information and stores its memory. A computer uses only zeros and ones. So again, like I said yesterday, I gave the example of like beans and beans. I'll give like a different example, but let's say we have like apples and oranges. So your program never knows the exact location where like an apple or an orange is stored. It can only refer to it by its name. So if I put an apple in my closet, but then I put an orange underneath my bed, it doesn't know, like the computer can't go and retrieve that apple or that orange. But what it does know is the kind of data type that is stored in that variable. It does know the difference between an apple and an orange. So whenever you store a memory, like you store something inside, like if you're going to store something inside your fruit, or if you're going to like store something inside your actual variable, your computer never actually calls to it based on its location, but calls to it based on what kind of data type it is. And that's why data types are so important. So again, we talked about this yesterday, but it's not the same thing to store a simple integer versus storing a floating point number. So a number like 1 is different than 1.0. Because 1.0 is actually a floating point number because it has a decimal place, and that's completely different than the number 1, because that's a simple integer. So even though everything is represented as zeros and ones on your computer, like even these texts that I have in front of me is actually behind it is a bunch of zeros and ones that's being created into like letters for us to read. Your computer can only interpret it as the kind of data type it is. So they don't occupy the same memory. So this goes back into kind of like the memory data types that we talked about before too, where each data type has a different memory storage with it. So, yeah. So a good point to make about this also is that there is like a difference between also the kind of data types, not only by like what type is, but also the memory that's being stored with it. So I gave the example yesterday, like an integer is 2 bits, but like double could be 4 bits. And that difference in bits is actually what the computer does to store its memory. So bits you can think of like as just like the data itself, like the way you store data is as bits. So you might have heard that you have like a 64 gigabit like computer storage. That basically means that like your computer can store that much amount of memory, and that memory is being stored in like different ways, and those different ways are your data types. And so that's why like having a lot of memory is a good thing, and that's why when Alfred said like if you have too much memory, your computer can crash because your computer can't like handle that much amount of data, and it cannot store that much amount of memory. But it's important to like take into account when you're creating your own programs what kind of data types you need to actually allow your programs to run properly. So fundamental data types are again just basic types implemented directly by the language that represents the basic storage units. All we're basically talking about here is that C++ uses these types of data. So the first data type is called single character. So you can think of single character as just by just using one letter. So A, B, C, D, all of these are represented by car or char, like however you want to say it, and these are character types. And these are 1 bit or like 1 byte characters. And so what we mean again by 1 byte is that to store this value of A into your computer, it takes 1 byte of memory. So to store A as a car, it takes 1 byte of your computer storage. So like I said, you have 64 megabits or whatever in your computer. That's one of those bits goes into storing this letter A whenever you're writing your programs or whenever you're running an application. So that's character types. That's like letters. Numerical integer types are actual numbers. So these are specific to whole numbers. So these are like your counting numbers, like 1, 2, 3, 4, 5, and so on. So it says here they can be either signed or unsigned. All that means is like you can have negative values and not have negative values. So it includes even like -1, -2, and so on. The other data type is the floating point types. And this is what I was talking about with your decimal places. So it represents like real values like 3.14, which is pi, or 0.01. And there's different levels of precision. So by precision, we're just talking about how many places past the decimal point is possible for you to make. So if you want to like give like the full form of pi, for example, the level precision is going to be different between like 3.14 and then you continuing on like all the different decimals past it. And so again, it depends on like what floating points you're actually going to be using. An important note that I just talked about is there's a difference between 1 versus 1.0. And you really, really have to remember that because 1 counts as an integer type. That's a whole number that doesn't have a decimal point. But 1.0 is automatically a floating point type because we have a decimal and we have that kind of level of precision in there. So whenever you store a data type in your computer as an integer, you are never allowed to use a decimal point. I'm telling you, this is something that a lot of programmers kind of mess up and kind of forget. And so they'll store an integer as a floating point type, and they'll assume they equal the same thing, even though they do not at all. And then the last fundamental data type is Boolean. So if you know like Boolean logic, this basically just refers to like true or false. So if you're like in my pre-algebra class like earlier today, then you might remember us talking about like logic statements. This is kind of similar to how whenever we looked at the statements that were given to us and we were determining whether these statements are true or false, the Boolean data type is the one that's actually like relating those values to the computer in the first place. The Boolean data type is the one that determines whether the statement you have given is actually true or false. And so again, these are keywords. So that like big crazy list I had at the end of this previous slides before, one of the keywords are these Boolean types, like true or false. So of course you can never like name a variable as true or false because that's something that's already being reserved by your computer.